Hi, everyone. Thank you so much for joining today's webinar, the USGS Landsat program. My name is Emily. I'm the Chief Technology Officer at the National States Geographic Information Council. If you're unfamiliar with NSGIC, we exist to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. And if you'd like more information on how to get involved, please visit our website, www.nsgic.org. Just a couple of reminders for today. Everyone's been muted upon entrance, and there will hopefully be a little bit of time at the end of the presentation for Q&A. So if you have any questions, please put them into the chat. There'll also be a few USGS staff members answering questions in the chat. Additionally, this webinar is being recorded, and the recorded version will be made available afterwards and sent out to everyone who registered. So please keep an eye out for that information. And with that, I'm going to hand it over to our presenters. Thank you so much.
Thank you, Emily. I'm Tim Newman. I am the program coordinator for National Land Imaging at the U.S. Geological Survey, USGS, in Reston, Virginia. I have the pleasure of briefing you today on Landsat, and my staff is available, as Emily said, to answer questions in chat as you might have them. So feel free to pepper them with questions in the chat if anything comes up. We have a pretty cool briefing for you today. I love Landsat. I've been working on the program here at USGS for 20 years this month. So it's been an amazing run. I worked a lot of Air Force space activities and missions prior to that. So it's been great to be on the civil side of space. So as Emily said, we're going to launch through the charts. In the end, hopefully we'll have some time for additional questions. If you have any, we've tailored this briefing for you. So we want you to see that there are data sets and products here available for you in what you do every day with your jobs across the country. And so we have a lot of websites, a lot of links, a lot of different products, descriptions for you so that you can, dig right in, and hopefully some of these will make sense to you. And I hope many of you are using Landsat already. So with that, Doug, let's proceed to the next chart. So the first chart just basically describes what is Landsat. Maybe many of you have heard of Landsat. It's a satellite program that's been up for 50 plus years. So the first one launched way back in 1972, before there were any real satellites taking imagery of the land surface. And so hence the name Landsat. We've been continually operating satellites ever since 1972. So we're into 54 years now of continuous operation of different satellites in the Landsat series. Each one gets a little better than the previous one in order to meet the needs of the user community. So Landsat does a lot of different things. It's called kind of the Swiss Army knife in space because it has so many different applications across many federal agencies, states, and the private sector. You can see those down in the lower left. And then on the right, some of the key attributes of Landsat. You're looking across the spectrum from visible, near infrared, shortwave infrared to thermal infrared, all with one satellite, with one system. The spatial resolution varies with the different sensors, but the best you get is a 15-meter panchromatic, and then you can go out to 100-meter on the thermal infrared sensor. With two satellites, we get 8-day revisit of the entire globe. So this isn't just the United States, this is the entire world that we collect. Broad area collection. So each image that we collect is about 12,000 square miles per image. So you're talking about with 1,500 images with the two satellites collecting, that's about 20 million square miles every single day that gets collected by the satellites and put into the archive and made accessible for people to access. The difference with Landsat is it's very superbly calibrated data. So it's truth data, if you will, science quality data that actually helps the commercial imagery providers improve their products and services because they can always look back, what is the ground truth? Sometimes in space, sensors change and warp with all the repeated cooling and heating that happens in space. And so Landsat, we take very great pains to understand how the sensor changes over time and make sure we can compare the data so that if there is a change detected, that's a real change on the Earth's surface and not some aberration with the instrument. So we take a lot of care, a lot of resources go into that. And of course, since 2008, all of our data and products are free and open to users. And so we went from a few tens of thousands of scenes distributed back in the days when we sold the data to now billions of data and product accesses every year across the globe through the cloud services that we provide. So this is your one shot snapshot of, if you will, of Landsat. But we're going to go into some more detail on this before we get into the applications. Next slide. So I mentioned, that Landsat's been on the scene for 50 plus years. And as you can imagine, with a data set like that, it's really basically gotten into everything. So everything that's out there today that's involving Earth observation somehow will take Landsat data in some form, maybe not in its raw form or its processed form, but in products that are developed either by the federal government, products developed by the commercial sector that are then used again and again by users out there further as you get further away from the source of the data. There are many users that don't even know that they're using Landsat data. They're familiar with a certain product like the cropland data layer or certain products like the National Land Cover Database. And so you really don't know, some people don't know that Landsat was the core data set that started that process with the intermediate products. So this is just a snapshot. Every one of these references, we have actual data to show how they use the Landsat product. And this is just part of it. This is obviously not all of it. So it's a pretty impressive list. If you go to the next slide. Why do users pick Landsat in the first place? I think one of the reasons is we have this archive that goes back 50 years. No one else has that type of record. We collect the entire globe, so we're not focused just on the United States, but we do collect a lot of data over the United States. It's free and open. We have that broad suite of spectral performance, so not just visible near infrared as the commercial providers give you, but also out into the shortwave infrared and the thermal infrared. That allows you to see things that are happening on the Earth's surface that you wouldn't just see with the visible or near infrared. You can see out into these other spectrum regimes. And then the gold standard calibration that I referred to earlier. We take a lot of pains to understand how the sensor changes in space and then make sure each new satellite that we launch is carefully calibrated with the previous data set so that we can have a 50-year record that's consistent. Next slide. So I spoke, this reinforces the accuracy, the Landsat accuracy. So why does accuracy matter and what is it? There's geometric accuracy, which is where are you placed on the surface of the Earth? You guys are probably well aware as GIS professionals why geometric accuracy matters in everything. But there's also radiometric accuracy. How accurate is the pixel, the reading from that pixel? Is it the right value that your sensor's picking up in space? Several hundred miles above the surface of the Earth, is what you're seeing from space, is it accurate? Does it actually reflect what's on that piece of land that the pixel is looking at, the 30-meter pixel? And so together, because Landsat does both of these really well, it makes it a scientific measurement tool, not just a camera in space. And why does that matter? As I said, as changes happen on the land surface, some can be very subtle. And so if your instrument is seeing a change, is it real? How do you know that really happened, or maybe it didn't happen and it's an aberration of the sensor? But that's why we do that. And that data then underpins decisions that are made across the U.S. Department of Agriculture, national parks, as they look at their land area and see changes, and also maybe help forecast what's going to happen in the future with my parcel of land based on what you've seen happen in the past. So decisions are made that rely on this data, and so the data has to be accurate. The accuracy of the data, again, in the lower left, there's a quote how users have rated that. Some people say, I just want more data. Some people say, I want to make sure the data is accurate, and that's why Landsat really matters. On the right, there's an example of a case study, and we have a large number of case studies that you're going to see through the course of the presentation, but this focuses on the Great Salt Lake. And understanding the exact changes to shoreline over decades, it matters as you're studying that lake and how its effects on the surrounding community. Next slide. So I mentioned that this has been a series of satellites that launched first. The very first one was back in July 1972. And there's been a series of satellites all the way up to Landsat 9, which was launched back in September 2021. And we're all starting work on Landsat 10. We've been working that for the past couple of years. These missions take a long time to develop, sometimes 7, 8, 9 years. So we've been on Landsat 10 for a while, great improvements there from previous Landsat, but pretty much every new Landsat improves the previous version. So, and it does it not just because we can improve it, we improve it because the users say we need better measurements. We need to be able to see things better spatially, spectrally, or temporally. And so that's why improvements are made to the satellites. Next slide. So this was interesting too. The recent sesquicentennial, the July 2026, there was a call out across the federal government for a lot of agencies, put something together for to celebrate the 250th anniversary of the country. And so we actually were able to go back in July 1976, the bicentennial, which I remember really well as a kid. There was a Landsat pullout, first of its kind national map, if you will, of the United States based on Landsat data that had been collected from 1972 up to that point. So the resolution was not as good with those early sensors. It was 90-meter spatial resolution as opposed to today's 30-meter. But that was the first one, and it was published in National Geographic. And so we kind of found that and said, hey, let's do an update. And so the team put an update together for July of 2026. Of course, you can look at it now. It adds elevation data to the product in 30-meter spatial. But it just speaks to how long Landsat's really been a part of this country, part of America for this long. And so that's the legacy that we've had, and we want to carry that forward into the future. So why does Landsat matter to the states? You may be asking those questions, and maybe you've already seen some of the applications we touched on. But across these six, for sure, a lot of value there as states manage their lands and cope with disasters and land use planning, fire, managing our forest environment, water. So it isn't just Landsat. I mean, we also deal with surface water across the country, lakes, rivers, streams, and also coastal regions. And then, of course, agriculture has been one of their primary application areas throughout the history of Landsat to understand what's the crop condition, irrigation, and the yield of crops throughout the year. So that's why this matters to states. And we'll get into these in more detail in a moment. So the agenda, which you've already seen the program stat, well, we're going to get into some program status also, but I gave you a preamble of what Landsat's about. Then we're going to get into some more specific data and products and some case studies, how you can get to Landsat data and products, and then some key takeaways and resources. So we have two satellites in space, as I spoke to earlier, Landsats 8 and 9, Troopers. Landsat 8's been up since, I think, 2013. And Landsat 9 since 2021. Sometimes these satellites last decades, sometimes they die early. The space environment is unforgiving and hostile. But right now we have two really highly functioning satellites, each collecting 750 new scenes per day. So as I said earlier, that's about 10 million square miles of new territory every day that we add to the archive. And I think as you look at that, you think, well, 20 million square miles. So, I mean, that's like Europe and North America. So you're talking about a lot of land area from around the world being added to the archive every day. Looking ahead to Landsat 10, it was called Landsat Next up until recently. It's been reconfigured into a single satellite. There was at one time 3 satellites. And so now we're focused on a single Landsat 10. The good news is all of the capability from those satellites is being retained with the new Landsat 10. So 26 spectral bands, up from just 11 today, twice the spatial resolution. So we'll be down to 10-meter spatial resolution for many of the bands. And that, of course, allows you to see much finer detail on the surface of the Earth. But we're going to maintain the calibration and the accuracy that we've had with historic Landsat. And you can see on the right all the different bands that we've been adding. Again, the bands are added because of user surveys that we did. We went across the community to find out what do you need out in the 2030s when this mission gets launched. And so as we looked at and talked to users, they wanted more spectral information across bands that we weren't really getting that information before. So there are more thermal bands, for example, 5 instead of the current 2. And then a number of other changes were made. The temporal revisit, because this satellite actually will be in a slightly different orbit than today's satellite. So this single satellite will give about 18-day revisit. The goal is to actually put 2 more satellites up there, potentially commercial satellites or versions of Landsat that will be in that orbit that could give us better revisit. Launch date is around 2031, and then you can see the rest of the information there. So all of it is still going to be free and open and continuous. So there's no change envisioned in the data policy for Landsat. So we're still going to continue to make the products and the data free and open. Any type of commercial transition we make for missions beyond Landsat 10, we hope to retain this policy because we do think it's important for users to know that it's going to be there. Not only has it been there for decades, it's going to be there for decades as well. So you can learn more about it and make sure that that capability gets added to your states. So the satellite data, when it comes down, if you were to see the satellite, the raw data coming from a satellite, it would make no sense to you. It makes no sense at all. It's just a bunch of zeros and ones. And so what you're seeing, what we realized long ago is that the data itself is really not important, and other than the sense that you take the data and turn it into products. So level 1 data is the most basic raw data, basic geo-registered. It's calibrated. It's what the sensor sees from space. Level 2 is how do we take that data and make it to show what's actually at the surface. And so there's an algorithm that gets developed and updated periodically to translate the sensor information down to what's on the ground, what's actually there. And again, with Landsat, we do a lot of calibration. So to make sure we go over test sites on the ground to compare what we're seeing from the satellite versus what is actually on the land. And so that allows us to make sure that the data we get is accurate. So level 2 data is referred to as things like surface reflectance, aquatic reflectance, land surface temperature. So those are basic products. Level 2 products are wildly popular. No one really takes the level 1 data, but most users come and take level 2 products. And then level 2 in turn, those are turned into what can best be described as maps. So consistent maps over space and time. Most users can also access level 3 pretty easily. Level 3 actually makes sense intuitively if you're not a remote sensing specialist. So it's gridded map data directly derived from the Earth observation data. And then we include that in many of our products like analysis ready data, dynamic surface water extent, burned area extent, vegetation indices, and so forth. But again, the goal we have here is to generate products that are useful to as many people as can make use of the satellite across the country. And so we recognize people are not remote sensing scientists. And so we try to create products that are useful to that group. And then level 4 goes even further with more of a modeled understanding of the system. Our National Land Cover Database, NLCD, which we'll get to in a second, is our most popular product, probably our flagship product. And then we have also rapid transpiration and drought products. So when can I access the data? So this graphic gets to the time between when a satellite actually sees the ground and collects that imagery to when it gets turned into a product that you can access. So Landsat 8 and 9 are different slightly because Landsat 8 is older. It's had a failure in its thermal infrared encoder. And so what that's had to do is it's lengthened the time for us to generate some of the products that are associated with it. But in all cases, within about 4 to 6 hours, for the most part, you can see that data will come back to EROS, the Earth Resources Observation and Science Center in Sioux Falls, South Dakota. They collect all the data, they archive it, they process it, and distribute the products. So it takes about 2 days to add auxiliary data. So there's extra data that we bring in that could be related to the weather, atmospheres, temperature, and so forth that we have. And then together you create, in some ways, it's like a recipe for the products that we develop using the latest science and the latest data that we have available to us. But generally within 24 hours with Landsat 9 data, the product will be there and available for you to draw and take a look at. And then level 2 takes a little bit longer, up to 3 days. And then level 4, for example, National Land Cover Database we update that once per year. So the NLCD, which we'll get to in a minute, it's a pretty intensive national product that covers the entire contiguous US. It doesn't have Alaska and Hawaii just yet, but it takes about a year to actually update that. And so every year we put out a new version of it. And then on the bottom, you can see it takes a little bit longer for Landsat 8 because of that issue that I spoke of earlier. When we get to level 3, so level 3 are the analysis ready data, ARD, tile-based science products and applications. So again, what we're trying to do here is make it as easy as possible for users like you and others to grab these products over areas of the country that you're most interested in, and then pull these products. So these are 3 of our best level 3 products: Fractional, snow-covered area, and they are just like they sound. So you can look over a 30-meter pixel and see how much of that is snow-covered. And so because we've collected this data as rigorously as we have over decades, you can go back in time and look at any pixel, 30-meter pixel in the country, and see what did snow cover look like at any time in the past, going back decades and all the way up to today. So you can see how that changes to get trends in snowpack, for example, snowfall patterns and drought monitoring, and also fire management related to snow level data. Dynamic surface water extent is looking at just what it sounds like, the extent of surface water, whether that's rivers, streams, lakes, along the coastal regions. And so that product is very useful for water use and management, habitat assessment, and flooding assessment. But I think, again, I want to keep emphasizing the time series nature of these products. So it isn't just today's collection to look at it, but you can look back over decades to see how it's changed from decade to decade or year to year. And then burned area, of course, is a huge one as well. Fire severity, trend monitoring, managing a forest, and then what's the probability that a burned area will happen. And so these are the 3 big ones. We're going to get into these in a little bit more detail here. Next. So starting with dynamic surface water extent, DSWE as it's called, Landsat collection 2. And a collection, when I refer to the term collection, what we've done periodically is reprocess the entire archive of data, the 50-year archive, or at least 40 years of the 50, and we process it in a different way that retains the accuracy of the data, but in some ways changes what actually was happening on the surface if you go back and look. So it comes with the latest information on atmosphere and other updates to fix issues that come up with remote sensing from space. And so what we try to strive to do is create a new archive that's easy for you to go back and forth through time to look at a certain pixel. So that's the purpose of the collection activity. But this product provides raster layers that represent surface water inundation per pixel. And there are 6 acquisition-based raster data products related to DSWE. We have links throughout this brief, so you can see the DSWE link down on the lower left. I really encourage you, this is a reference we're leaving behind. You can go in and look at what's in there. For this one, the example on the lower right, you can see it's the confluence of the Wabash and Ohio rivers, just looking at a particular DSWE product on the far right. But the point is to, again, monitor how the water changes over time over the contiguous US. Next. The burned area product is incredibly popular. A lot of, especially in the US West, that's been utilized extensively in studying how fire moves and looking at the vegetation, the burn condition of vegetation. But you can go back through time and see where have all the fires occurred over the United States. And And so then you can take a look and see year to year, month to month, even week to week, how does that change over time? And so that is all there for you. Again, if you have a state you're interested in, you could get this information for your state to show how the fires have progressed and changed over the last 50 years. So a lot of tremendous information there on the burned area. And then finally, the fractional snow-covered area. Again, we're trying to understand the snow cover, the duration and persistence of snow cover using this product. And so you can look back. So Landsats 1, 2, and 3 were a little different, higher orbit, a little different capability. So many of our products, the best products, are utilizing Landsat 4 and on. And so in this case, that's what fractional snow cover does. So again, if you have an area, if you want to look back and see what did the snow cover look like over a certain area over time, you can do that. You can make that run with this data set. Okay, SEAM-based products to meet state GIS needs. So here are two additional level 3 products that we call them provisional. That means they're kind of in training, if you will. So they're products that we introduced a couple of years ago, and we're still learning how to refine them, improve them, to understand how to make them better, how to make them more effective. So these are, in a way, they're kind of like test products to look at aquatic reflectance. It's a worldwide product, and then actual evapotranspiration, which is also worldwide. And so these products are available for you to take a look at as well. And then land cover data products and applications continued. I wanted to mention again, these are 3 we're going to talk about in a second. The National Land Cover Database, which is used for those purposes, as you can see, asset management, habitat, urban planning. The rangeland condition, monitoring, assessment, and projection. You can see again the purposes that why do we have a product like that? It's for analyzing vegetation change over time, assessing ecosystem health and wildfire risk. And then the final product on this category is the LANDFIRE product suite. LANDFIRE is a combination funded by Interior, which is our department, and the U.S. Department of Agriculture to fund that product. And that product models wildfire risk, habitat analysis. It tracks disturbances over the landscape and helps with fuel, understanding what the fire fuel looks like in an area, which of course is very important to firefighters in that area. So first, the NLCD, or National Land Cover Database. We just released our latest update just, I want to say, about a month ago. And so again, this is an annual product. It has 6 different products across land, so that you can see it on the right side: land cover change, land cover confidence, fractional impervious surface, impervious descriptor, and spectral change. And so those are all available. 1.2 is out there now. This year, and all previous years, it's just been the contiguous US. Starting next year, hopefully, we're going to be adding Alaska and Hawaii to this. So we'll have Alaska also modeled under the NLCD, and Hawaii. And so what we find is, because there are so many uses for NLCD, we've treated it as our flagship product. So we invest in it. We try to make it as strong as we can, as accurate as we can, but it's used for so many purposes across the country. And then rangeland condition, which I mentioned earlier, that is also a partnership with another agency, the Bureau of Land Management. And so we look, and for many of these products, agencies identify a need and then come together with funding to develop them. And so that's what rangeland condition monitoring, assessment, and projection, or RCMAP as it's called, across the Western United States. Again, you can look at the resolution. You can look at drought impact analysis, wildlife habitat, for example, the sage grouse and what's happening with that, invasive species tracking, grazing, livestock management, fire risk assessment. Again, we have links in these charts so you can go access them, but Rangeland RCMAP is, again, one of our more popular products. And then LANDFIRE. LANDFIRE has been around for quite a long time. Again, a multi-partner project that we do with USDA to understand fire fuel. And so that product has been really important in understanding fire behavior and planning for that, fuels treatment planning, and cross-boundary wildfire response. And so there's a land cover, an example of LANDFIRE, one of the maps that's put out, and you can see um, all the different classifications in the color codes down in the lower right of that graphic, land cover classifications that are included with LANDFIRE. And here are some more. So the ones I've mentioned are probably the preeminent products, but there are quite a few products out there that make use of Landsat. And the USDA Cropland Data Layer is one of those extensive products. Again, these products often use other data sets as well, but Landsat is maybe the base or foundation of these products, and then other data is brought in to augment them, to improve their products. And so you can see across HLS's harmonized Landsat Sentinel. So the Europeans have a Sentinel-2 mission that's very similar to Landsat in the spectral bands and the spatial resolution. And so users, because you have two Sentinel-2 satellites and two Landsat satellites, if you don't need thermal, then you can actually get revisit less than 3 days. So any area of the country or the world, you can get a revisit less than 3 days if you utilize both of those, all four of those satellites. And that's what NASA's harmonized Landsat Sentinel product does. DSWE-X is my understanding is, again, it's a NASA product that ties Landsat into other data sets to look at global water use, and very similar to the DSWE product that I mentioned earlier, dynamic surface water extent. OpenET is it's a product that's out there commercially. It's open. It's called, it uses Landsat's thermal imagery as one of its data sets when it determines evapotranspiration across the country. And so it's a wildly popular product that's out there that makes use of Landsat data. And then MTBS and Bayer are also fire-related. Burned area emergency response is Bayer. Monitoring trends in burn severity is the MTBS. Both of those are slightly different products, but again, they're related to Landsat's ability to see fire, the effects of fire, and help us understand how to respond to fires that have just gone through an area. That's the Bayer team folks. And then monitoring trends that are happening in fires across the country, which is MTBS. And then FIRMS, another product that's out there, and you can see on the right, there's exotic annual grass, stream, and vegetarize. So we have the links to all these. So if you're interested, again, I would encourage you to go try out the links and check these products out, because I think there's a lot of use cases out there for you potentially. Okay, supported applications. So how do you get to those data sets? You can hit those links. Those give you good descriptions on the previous charts of what those products are. And some of those will actually show you how to get to the products as well. But these are the applications for which you can click in, and how do you get to products? So USGS Earth Explorer is our flagship dissemination application. So if you go to Earth Explorer, all the data sets are available to you there. And then there's all of our data is available on the commercial cloud. We did that a number of years ago, and that's dramatically increased awareness and usage of Landsat data. You can also, we have a bulk download web application. There are machine-to-machine APIs out there for you to use. There's GLOVIS is another tool similar to Earth Explorer that allows you to go into visualize data sets that are available. ESPA is an Eros, basically a sandbox for us to try out new applications and tools. So that's a product we have, or an application we have. And then NASA application for extracting, exploring, and analysis samples. So you can see there are also many folks out there that take our entire archive and mirror it and make it available through those links. And so Google Earth Engine is one of those. Google Earth Engine has been taking Landsat data for years, and they just basically move it all over to their platform. So it's available there. Esri is another example, the Landsat Explorer tool that they have, Copernicus browser. So these are private sector, but they're making use of our data in ways that we love. So we want to get the data set out there. taxpayers are paying for this system, so we want to get maximum return. Okay, some examples across government. Here's one for California. So California vegetation burn severity data. This is an app that we found. So you can see the problem. Land managers need a consistent statewide burn severity data for all the wildfires they've been experiencing. And so here's how Landsat helps. The Cal Fire produces its official vegetation burn severity data set by running Landsat through Google Earth Engine and then recalculating the normalized burn ratio. So the result is they published this Landsat-derived severity data through its web app covering fires from 2015 to 2025. So we have just a couple of examples here for how states are using Landsat data. This is just an example focused on the burn severity data. Idaho has been a strong user for the evapotranspiration, or ET, application, which basically uses the thermal infrared sensor on Landsat to measure temperature on the land surface. So if you know temperature, then you can tell across a land area what areas are being watered and which areas are not, because water cools the vegetation. And so it's very, with some of the other bands on Landsat, you can take this data and it's a proxy for actually sending people out into the field with their monitor, with their meters to understand water use in certain areas. So instead of sending 100 people out over a long period of time across an entire state, you can just instantly get this measurement from space, from Landsat, and then that allows you to determine where is water being used, how the irrigation practices of your farmers, for example. You can look at water budgets across the states. So this has become a big thing for understanding the dynamics of water use across the Western states. ET has been a big factor there in trying to understand that better. Minnesota, a lot of lakes, 10,000 lakes. And so what Landsat can do is you can leverage it to produce water clarity assessments over those lakes, published all the way back to 75. So DNR in Minnesota has been doing this, using the data to examine the current status of lake water quality and looking at how it changes over time, along with the warming temperatures, and how does that affect the fish. I want to mention AmericaView. Maybe some of you have heard of this, but it's a grant. It's a consortium that won a grant program that we have within USGS. And what AmericaView has been around for quite a long time. It's in, I believe, 44 states across the country. They have 44 of these things called state views, and they're university-based. So this grant pays for a couple of folks part-time at 44 different state universities. And these folks are experts in applying Landsat data to local and regional applications. And so we wanted to make sure you have this information so that you can reach out if there's an AmericaView chapter in your state to the folks that actually work in your state on some of these applications. I think they might be able to help you do further things, or basically give you an understanding of how Landsat's made a difference in your state. So we think it's a great resource. AmericaView has been wonderful over the years in promoting the use of Landsat, but also developing regional and local applications. And then every so often they get together and they compare all their different applications from across the country. It's an amazing organization, and I would encourage you across all the states to reach out to your local rep if you have a chapter in your state. Okay, getting started and next steps. So here's a common state workflow. So you might, if you're looking at this, you might say, how do I make sense of this? Well, define an area of interest. So is there a state in particular, the whole state? Is it a county, watershed, or maybe some boundary that you want to take a look at? Then you can say, okay, do I pull the Landsat science product that's applicable for your use case? So if it's water, it might be DSWE. If it's snow cover or snowpack, it might be the fractional snow cover. Fires are common all across the country, so it might be a fire product. And then the next step is to integrate it into your state GIS. So load it directly into the existing layers and workflows. And then hopefully that will help you support the decision your agency needs to make to act on the data that you have there. We'll get into this in a little bit more. So using Earth Explorer. If you go into Earth Explorer, when you first get there, it's a little daunting. There's a lot there. But you register first. So you open up an Earth Explorer account. It's free. You just log in and then you select your area of interest, as we were just describing. Select the dates of interest. So the dates refer to when was the imagery collected, or what are the products, the applicable product dates for when the imagery was collected. You can also set a cloud cover threshold. Some, of course, as we come from space, some images are completely cloudy, right? And then others are not. So you can specify, would I accept an image that's 50% cloudy? Does that still make sense? And then step 4 is you select the data set. So there's different types of products, as I just mentioned, different processing levels, and you can pick that. Then you review your search results. You download whatever you see there that you want to use, and then you can analyze that and then make decisions based on it. So that's a simplified tutorial. We do have experts that are available to help you if you're struggling with that, or if there's a step there that doesn't make sense. We also want to mention, that there's a lot of commercial data out there. So Landsat is one data set. It's a government managed system. There are a lot of commercial data sets out there, and there are ways for you to get to that commercial data. So this particular way references the Civil Applications Committee, which we manage across the federal agencies. And there are some tools and platforms there for you to access these commercial data sets. And you need to do that. In order to do that, you need to be a federal partner. So you have to qualify, but it isn't necessarily difficult to do that. It just requires a little bit of investigation. You may find that there's a federal agency doing something that you want to do also within your state, and that may qualify you to actually use the commercial imagery through this mechanism. Again, it's free. It's not something you have to pay for, but you can request accounts to access high resolution tools such as global enhanced GeoInt delivery capability from Vantor. And all this is overseen by our Civil Applications Committee. Another way is through NRO's Commercial Systems Program Office. This is kind of how you get started in what we were just describing. These are the data sets that are available to you through that mechanism. So you can see a lot of the popular commercial imagery data sets are there. And so you can actually access the CAC to find a federal partner to go with you to get that data. And then the National Civil Applications Center is our center that hosts this activity and manages it. So again, we have contacts there that can help you go through this and figure out how to get to the data you need. So getting started, where to get help and stay connected. We have a few points of contact here. I mentioned EROS earlier, the Earth Resources Observation and Science Center. That's our USGS center out in Sioux Falls, South Dakota, that takes all of our data sets. They take it and turn it into products, and they disseminate it and make it accessible. So those are the experts that do this work. I'm the manager or the coordinator of the National Line Imaging Program here in the headquarters, the USGS headquarters. If you have a question about where to go to get something, you can come to me. If you have a question about how to use these systems and services, you can go to EROS, customer service. That will be the right place. And then there is a Landsat newsletter that you can sign up for if you like to get monthly updates on what's happening. And then there are a lot of trainings out there across these links, both NASA, USGS, and EROS, that will allow you to maybe get introduced to some of the products a little bit further if you're interested. So I want to also put a plug in for our National Geospatial Program and the National Map liaisons that are out there on the field, on the scene, and you can see the names there within the different regions. The National Map relies on those partnerships, the relationships with you, the partners, and our folks. It's really important for them. Those liaisons are available. They're out there working across the country to make sure that the NGP program with the data sets they develop, 3DEP and hydrography data set and others that they're used out there in the field. They're interested in getting their products and services out there to as many people as they can access, just like we are, to get the most for the federal dollar that's invested there. So they are there. Contact them through that link that you see there on the left. I think we're about wrapped up here. We're curious, we would like to hear from you, not necessarily right in this meeting, but if you want to pass along stories of how you're using Landsat today, that would be really useful for us. We have to basically go down to Capitol Hill and defend our program and look for resources for our program. For the Landsat series to continue means we need to be able to tell the stories of how it's being used out there across the country. So those stories, if you have some, are very powerful and they make a big difference. We're also curious, like, what do you need? What do you need as far as how could Landsat data and our products serve you better? Are there different ways that we could tweak things to make them more useful? And we're happy to meet with you again, schedule follow-up sessions whenever you want. Our staff is here and available. There's some of them are online, but feel free to reach out because we want to try to, improve your jobs as much as we can, and the performance of everything we do matters to the public. And so whatever we can do to help, we're here. I think, so final takeaways, just to let you know, I mean, there's a tremendous wealth of data that's there. It's accessible to you and free to you that goes back decades. So there isn't any other record like that out there. So that record's available to you. The products are continue to improve as we try to take some of the remote sensing scientist pieces off and make them more accessible to users. I think there's a lot of direct relevance to all of our core agency missions, whether that's a federal agency or whether you're a state, and more capabilities coming. Landsat 10, it's very exciting that we're developing this new mission. The spacecraft the spacecraft request for proposal just went out from NASA. The imaging instrument is already well into fabrication by Raytheon out in El Segundo, California. So we're excited about Landsat 10 and what's coming down the road. All right. Hopefully, I haven't been able to watch the chat all this time, but hopefully my team's been answering your questions. But we can take more specific questions now too, if you like. Otherwise, back to you, Emily.
All right. Thank you so much for that presentation. I know I've been keeping an eye on the chat as well. We've had some good questions and some good answers in there. But if anybody has any additional questions, feel free to use the raise hand function or come off mute and ask. Lots of applause, I see. Good job, good job.
Were there any questions in the chat that we were not able to answer, or does it look like we captured them all?
I think it looks like we've captured most of them. I mean, it's gotten pretty big. So,
but that's good. I love it. I mean, that's why we're here, is to try to communicate with you. We've never actually briefed this group before, and so I was kind of excited to see a different group. A lot of thanks go to Iris Garthwaite of my staff for pulling this material together to really tailor it to you folks, to the audience that you have. And so hopefully this was helpful to you. And again, feel free to reach out to us anytime if you have any questions, or if you want us to repeat this to somewhat a different group within your state, we'd be happy to do that as well. If there's more of a remote sensing group there that would make sense for us to talk to, please reach out.
Wonderful. Thank you so much. All right. Any questions from the crowd? Sometimes it takes a minute just to let it perk, but go ahead. Sorry.
I was just going to say, if there aren't questions, Chris McGinty, are you online? I was just going to say, and maybe he's not able to get on, but maybe you could just say a word about AmericaView if you're on, Chris, and just take a minute.
Oh yeah, I am, Tim. I'm not really.
Sorry to throw. I didn't prepare you for this, but
I'm in a t-shirt. It's it's a warm day in Utah. No, but thanks for the opportunity. For those of you that had an opportunity to hear what Tim said about AmericaView, we're a national organization in 44 states. Each state has a state view program that really focuses on local issues using geospatial data, Landsat, those sort of things. we have many members that are part of NSGIC in various states. And so if you have questions about AmericaView, if you would like to get in touch with your local state view network, my email's in the chat. Feel free. We do a ton of education and outreach with STEM education as well. Amy, I saw that you had a question there. We have a lot of resources at the AmericaView website. Head on over to americaview.org. You can download all those resources free. And so this is all, very geospatial, Landsat based, but go Landsat. Big plug for what Tim and all the folks at NLI do. Thanks, Tim.
Emily, you're muted again.
Oh, thanks. The good old double mute strikes again. Cool. Thank you so much, Chris. I think if we do not have any more questions, we can end a few minutes early. But yeah, thank you so much again. This meeting recording will be made available on the NSGIC knowledge base, hopefully no longer than a week after, and it will also be sent out via email to everyone who registered. So keep an eye out for that.
Thanks again for the opportunity. It's always fun to see new groups. Sometimes we get used to seeing the same groups every year, but I'd love to come back again at a future date if you guys see the need for that.
Yeah, that would be lovely. Thank you so much for the presentation. It was really great to have you.
Sure. All right. Y'all have a good day.
Thank you. You as well.